I really like this question a lot. In this lesson, we're going to confirm if two expressions are equivalent to each other. So let's look at this one, which looks spicy, but we're going to break it down into tiny little chunks that we can do. Is negative 2/3 times 9x minus 6 equivalent to negative 6x plus 4? So again, it looks spicy. I get it, because they're negatives and they're fractions and they're two expressions now. How do we know if they're the same if they look so incredibly different? That's what we're going to do. We're going to figure out if they have the same value. So what do we have? Clearly, we have two different expressions. We can see they both have the same variable x. So that's good. If there was a y in one and an x in another, they would not be equivalent because they would have different values there. And we do also know that one of the terms, one expression, negative 6x plus 4, is already in simplest form. That, my friends, is going to be our strategy. We're going to simplify expressions to their simplest form to make them look the same, just reorganize them. And we could also see that there's a term outside of 9x minus 6, so we know we're going to do some distribution. Okay, so here's our plan. We're going to simplify that first expression to see if it's equal to the other expression that's already simplified. We're going to distribute negative 2/3. That means we're going to have to do some multiplying by fractions, by negative fractions. And we're going to, I want to turn those terms of 9x minus 6 into fractions. So we're going to have 9x over 1 minus 6 over 1. That way we can multiply the fractions more easily. So see, we're going to chunk it out. It's not going to be so bad when we multiply the two fractions together. And please, please, please just be careful with your multiplication rules with positive and negative numbers. So please make sure we're paying attention to that. Finally, once we get to the end, after we distributed and combine like terms, we're going to compare our expressions to see if they are the same in simplest form. If they're the same in simplest form, they're equivalent. If they're not the same, they're not equivalent. All right, hit pause and jot this down in your notes. All right, let's jump into this plan. We're going to make sure they're both simplified. Let's start with the negative 6x plus 4, and this is already simplified. So already completely simplified. So we just have to deal with the other one. Negative 2/3 times 9x minus 6. We're going to distribute. Remember, put a little 1 at the bottom to help you out. So our first one is negative 2/3 times 9x over 1. And that's going to give us negative 18x over 3. Or if I simplify this even more, negative 18 divided by 3 is just going to be a negative 6x. And let's try with the other side. Negative 2/3 times negative 6 over 1. So negative 2 times negative 6 is a positive 12 over 3. And that simplifies to 4, positive 4. So here's my simplified way. Remember, if you simplify both and they're both exactly the same in simplest form, they are equivalent. So negative 6x plus 4 is equivalent to negative 6x plus 4. Both terms are equivalent. When negative 2/3 times 9x minus 6 was simplified, it gave the same result as the negative 6 plus 4. So when we simplify them, if they're the same, we know they're equivalent. So hit pause and we'll jot this down. And before we jump into the next one, I will say sometimes you're going to simplify them both and they will not be the same. And when they're not the same, they're not equivalent. It's time for another one. We're going to do another example to see if they're equivalent. So is negative 8j times negative 6k minus 4, close parentheses, equivalent to 48jk plus 32k? explain why or why not. So same thing, do they have the same value? We have two expressions. Both have, we see the j and the k are in both in some form, some way, shape, or form. Jk just means they're being multiplied together. So 48 times j times k. Whereas in the first term, I have 8j and 6k. But just an observation, our second expression, again, is already in simplest form. I can't simplify it anymore. I can't combine any other like terms. All right. And again, we can see we're going to distribute the negative 8j on the outside of the first expression. So here's our plan. We're going to simplify that first expression to see if it's the same as 48jk plus 32. That means distributing the negative 8j and multiplying. And you can see we're going to multiply a lot of negative times negative numbers. So remember our rule, negative times a negative is positive. And negative times a positive would be negative. Let's go to the next one. Once we've distributed and combined like terms, we're going to compare both expressions in simplest form. And again, if they're the same, they're equivalent. If they're not the same, they're not equivalent. So let's hit pause and we'll jump to this one. We want to see whether or not this equation will be true. Will both of these expressions be equivalent to each other? So I'm going to start by distributing on the left so I can simplify it to our lowest terms. And again, just so you can see our invisible work, I am doing negative 8 times negative 6 times j times k. All that is happening. And so negative times a negative is a positive. So positive 48 and jk. You may also ask, like, does it matter? What if I had 48kj? No, it wouldn't matter. It just make sure that when you're looking at it, that you can see that if you were comparing, you'd want to see they were exactly the same. So for example, some kids might write k and j and think, no, they're not equivalent, when they really are. They would still be the product of these two variables and 48. All right, let's distribute the other one. And negative 8j times negative 4 would be positive 32j. So again, I'm just not showing the invisible work that we're now doing mentally. And we have to look very carefully to see, are these two then equivalent? And if I were just doing a quick scan in my brain obviously sees these two numbers first, my coefficients, and goes, yep, same. And I see the j's and the k's, looks good. And that's where we have to slow our brains down to look really carefully. So I will say sometimes when we're reading from left to right, we may see things repeated, like our brains notice when things repeat and goes, yep, they look the same. Slow your brain down. You could actually stack these two on top of each other for a second look. So this is what I mean. What if I did 48jk plus 32j and 48jk plus 32k. Now that they're stacked on top of each other, yes, these terms are the same, but you can see the difference here. This is why they are not equivalent. So I'm going to circle that in. Not equivalent, because we know j and k are different values. Therefore 32 times j is not going to be the same as 32 times k. Let's put that into our final notes. The two expressions are similar but not equivalent. After distributing negative 8j, both expressions have the term 48jk, but 32j is not equal to 32. All right, so I'm going to hit pause there so you can actually jot this down
into your notes. If I had a little bit more room, I would explain that same reasoning I gave, that although the coefficient is the same, the 32 is the same, but J and K have different values. Therefore, these expressions cannot be the same.